Hey guys, so we're here talking about the quadratic formula today, and we didn't get to this last week, and that's all right. And we're going to take today and maybe tomorrow to work on this, and then Wednesday and Thursday for sure we'll talk about graphing these and interpreting the graphs of these quadratics. And what we're going to be using on those days is Desmos, the graphing calculator. And that is what I use to make the graphs that you see right here. And it's actually a very nifty tool, and it allows us to see beyond just the tedium of working out math problems for the heck of it, I guess. And it allows us to really see the patterns in that underlying um, that underlying mathematical relationship, which is neat. But we do need to know the quadratic formula because it is, a set of our standards, and it is something that you build off of in Algebra 2. So looking here, it says sometimes numbers don't come out nice. So sometimes these aren't factorable. There are no two numbers that multiply to be 5 or -5 and add up to be 3 or -3. It's not happening because 5 is a prime number. And 3, well, that's not a sum of 5 and 1. And so this doesn't factor. Does that mean that it doesn't touch the x-axis? Well, no, because there's all of these numbers between each one of these intersections, I guess, the horizontal and the grid, Um, so between this point right here and this point right there, there's still an infinite number of decimal points between any of those sets of numbers. And so this number right here, well, we can actually look at our Desmos, and let's zoom in a little bit and determine what this point is. And it's approximately 4.193. But looking at this, I know that that's going to be a fairly irrational number. And so I don't know how many decimal places this actually goes out to. But I'm going to say that 3 is probably a safe bet. Now, this one over here, I made this one up from a decimal number, but that's not important today. Sorry, getting off track here. So they can still intersect at any of these numbers, including irrational numbers. And so just because it's a prime quadratic does not mean that it doesn't have a solution. Now, looking at the second one here, sometimes they don't touch the x-axis at all. This does not have a solution. There's no number for x that will make this touch the x-axis. And so what that means is that it just swoops around and it goes back off into positive infinity before ever reaching the ground, as it were. And then there's this kind. They only intersect at one point. This one intersects at the point 6.3, and that's the way that I set it up. But these typically you would, it would be like the problem number 4 from our last week homework, where there was just one answer and it was, the perfect square quadratic. This is a 6.3 times 6.3, or negative 6.3 times negative 6.3, and this is negative 6.3 minus negative 6, or minus 6.3. So that's an interesting aside there. These diagrams were really just meant to prove the point that just because they don't factor doesn't mean there's not an answer. Okay. So before graphing calculators, how could we reliably determine where a parabola would intersect the x-axis? Now, when I was in high school, a graphing calculator cost $83, and they're not much cheaper now. And that was in, 2005 money, which, who even knows what that inflation rate is anymore. But they're not something that were widely available. Now we've got this free online Desmos calculator, and that's really cool. But before this was really widespread, everyone had to learn the quadratic formula. And on your assignment over here, this is still in the planning stages, you can tell, I have included this quadratic formula song, and I do insist that you watch it like 5 times. And it's going to get stuck in your head, but it's one of those things that if you have it in your brain, then you don't have to look it up every single time that you need to use it. And so the quadratic formula, A, B, and C, when you see those in here, those are the coefficients of the standard form of a quadratic. And then X is obviously what we're trying to solve for. And so that's this X here. So the quadratic formula, X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. And how we use this, that's what we're going to look at here. How we use this is I am not typing this every single time. That is not happening at all. So I'm going to copy and paste this in right here. Now, what's nice is that this is in ax squared plus bx plus c form equals 0, right? Everything is nice and pretty. Now, I'm going to be fully honest right here. This one factors. The reason that I chose this one to show you how to do the quadratic formula is because it's going to come out nice. When answers come out nice using the quadratic formula, it's because they are factorable. Maybe you just weren't thinking of the right numbers. When they come out to be this horrible, what did we call that? 4.193, whatever. When they don't come out to be nice, we know that they're not factorable. But this is how we can get an approximation for that. And when we're dealing with, rocket launches, trajectories, SailCat, all that stuff, with the gravitational pull of the Earth, those are most likely going to come out to be irrational, non-factorable numbers. So the A term here is 1. The B term is already negative 5, and the C term is negative 24. So here it says negative B. That means that we are going to take the opposite of what the B term is. It says negative 5, so instead of negative 5, it's going to be negative 5, which is positive 5. Plus or minus the square root of 5 squared. I guess technically negative 5 squared, but the point there is that it becomes positive. So 25, negative 5 times negative 5 is positive 25. Minus 4 times A, which is 1, times C, and C is negative 24. So let's delete the C, all over 2A. Well, again, the A term here is 1, and so 2 times 1 is just 2. And so now I'm going to do the math inside of here. And I'm going to pull up my calculator on my phone so that I'm not typing all over the screen here. But I'm just going to copy this again. Actually, I'm probably just going to copy this so that, there we go, so that I can do that. So negative 4 times negative 24 is really what I'm looking at there, because that 1, anything times 1 is just itself. So 4 times 24 is 96, and that negative makes it a positive. So plus 96 all over 2. And then I'm going to copy this and put it there. 25 plus 96. I feel like that's going to come out to be something perfect. It does. It comes out to be 121. And the reason that I figured that that was going to come out to be a perfect number is because I told you that this was going to be factorable. And so 5 plus the square root of 121 divided by 2, or 5 minus the square root of 121 divided by 2. And that's what we're going to be looking at here. So again, I'm going to, you know what? No, I'm just gonna write it like normal. And there's my font. There we go. So this means 5 plus 11, all of that divided by 2, or 5 minus, well, I guess I should put that in parentheses too, 5 minus 11, all of that divided by 2. And so whenever I do this, 5 plus 11 is 16. 16 divided by 2 is 8. And then 5 minus, dang it, sorry guys, 5 minus 11 is negative 6, divided by 2 is negative 3. And so those are the values of x. So that is how I would type this out. Whenever I handwrite this, I just, use the same process, except instead of typing over it and backspacing and copy pasting, obviously I just rewrite it every line. So there we go. Then you're going to do this one. It's very similar to this. See, very similar. I'm pretty sure this factors as well. But the purpose here is so that we have a low risk way to practice the quadratic formula before we get to something nasty down here that is just absolutely, I don't know, higher level, a little bit more challenging, potentially confusing. And so we start with the simple stuff. So looking here, I don't know if this one factors or not off the top of my head, because I jumbled all of these up so that we could have similar problems. But we're going to go ahead and copy this again. And then we're going to start. So this is an ax squared plus bx plus c form. Let me check on my time here. I might have to do 2 videos. Okay. So this is an ax squared plus bx plus c form. And so all I have to do is change the values here. So b is positive 11. So instead of positive 11, it's going to be the opposite. So negative 11 plus or minus the square root of b squared. Well, 11 squared is, oh dang, there we go. 11 squared is 121 minus 4 times a, oh dear, a is actually, not 1. So 4 times 4 times c is negative 20, all over 2 times a, and again, a was 4. So there we go. Now I'm going to copy this, and I'm going to do the math. 4 times 4 times 20, and actually that's negative 4 times positive 4 times 20. So negative 4 times negative 20 is going to be positive 80, and 80 times 4 is 320, because I can math. So hope that I'm not wrong there. I'm going to double check that because it's 2 o'clock in the morning and I hate being wrong. There we go. 320 is right. Alrighty, all over 2 times 4, and 2 times 4, of course, is 8. So there we go. All right. And so the next step, I'm going to add 320 and 121. And that's 441. And I'm not 100% sure if that is or is not a perfect square. So I'm going to do that on my calculator, and it is. The square root of 441 is actually 21. So here I go again. Forgot to make my line break. Here we go. Okay. So instead of the square root of 441, that would say just 21. So now, negative 11 plus 21 divided by 8, or negative 11 minus 21 divided by 8. Both of those are going to be our answers. So let me get this a little bit smaller. Negative 11 plus 21 is 10 divided by 8. And so that means 10 divided by 8, what is that, 5/4? So positive 5/4. That's not a 4. Okay. Or negative 11 minus 21, which is negative 32, divided by 8. Negative 32 divided by positive 8 is negative 4. And so x equals those two numbers. Okay. Don't know why I'm asking okay, because at this point you can't answer me, but now would be a good time to jot down a note or make a comment or whatever, that maybe this is where we need a little bit more emphasis, and then see about the next two examples and see if they help at all, and then if it's still an issue of clarity, then absolutely, and let me know about that issue. Okay, so here, this is not an ax squared plus bx plus c equals 0 form. And so just like what we did last week, we need to move all these things to the proper side of the equal sign. And so this would actually read x squared minus 3x, because we're moving it to the other side, minus 3. And 3 times 1 is 3, but 3 plus 1 is not 3. And same thing with the negatives. So this is definitely not factorable. And so we are going to see, like up here, obviously, with this being a rational number like that, and this being a nice, pretty whole number, this would have been factorable. This one is not going to be like that. And I'm going to show you exactly what we are going to do with problems like that. So this is going to be our first non-factorable quadratic. And so again, I'm going to come up here, I'm going to copy this, and the way I do that is just either double tap, like use both fingers on the mouse pad, double tap, and that brings up your panel here, and you can do that. Or I just like to do the key shortcuts and Control C for copy and Control V for paste. So now, my B term. My B term is negative 3, and so negative 3 would be positive 3. Okay, negative 3 squared is positive 9, because any number squared is positive. That's the whole purpose. Like in Algebra 2, you'll talk about the derivation of where this formula comes from, and that x squared, the entire purpose there is to make this positive. Anyway, the A term is, dang it, sorry, my mouse pad is incredibly sensitive. The A term is just 1, whoop-de-doo. And the C term is negative 3. Okay, and then the A term again is positive 1, so I'm just going to knock that A off there, because 2 times 1 is just 2. Okay, yay. Copy, paste. Negative 4 times negative 3 is positive 12. Okay, and that is that entire step there. Copy, paste. Okay, and then with this one, 9 plus 12. 9 plus 12 is 21. And 21 is not It is not a perfect square. And so I have two options here. I can leave it just like this. This is an exact form. 3 plus the square root of 21, which is exactly, oh gosh, I can't put it in the calculator and figure out exactly what it is because a calculator is going to approximate it. It's going to round at some point. Remember, these kind of irrational numbers, they go on forever, they never repeat, and they never end. So this is called exact form. Okay. But when I'm talking about Sailcat, when I'm talking about a rocket's trajectory, when I'm talking about shooting a basketball, when I'm talking about, how long will the football be airborne, that's when I'm asking a real life question. And so that's when we need to have an approximated number that makes sense. And so at that point, we would find the square root of 21. And we would plug this into, or do the same thing that we did up here, right? And so what that would look like, the square root of 21 is about 4.58. So let me copy this again. Okay, so here I just said that would be 4.58. And so 3 plus 4.58 divided by 2 is 3.79. And then 3 minus 4.58 divided by 2 is negative 0.79. And that is approximated. Okay, make that smaller. Because I don't like that it's taking up all the space. And so that's when we would actually take, the same thing that we were doing up here. Negative 11 plus 21 divided by 8. This is 3 plus 4.58 divided by 2 and 3 minus 4.58 divided by 2. Now, whenever you put this in the calculator, okay, I need to show you this. Whenever you put this in the calculator, it's important to know that the calculator will do the order of operations, and so you need to be smarter than the calculator. Don't just say 3 plus 4.58 divided by 2, because see how that gives you something completely different. What they did is they divided 4.58 by 2 first and then added 3. And so if you're using a calculator like this or on your Chromebook or whatever, you can go 3 plus 4.58, hit the enter button, and then hit divided by 2. That can work. Or if you just want to type it in all at the same time, 3 plus, use your, okay, how do I clear this? Sorry. Okay, use your parentheses, which you can also use on your keypad here. 3 plus 4.58, close your parentheses, and then divide it by 2. And that's going to give you the correct response. So please be smart about your calculator usage. All right, last problem. Let's see how much time we have on the clock. Oh, wow. This is a long video. Okay, I promise this one, and then I have nothing else to say. So this, slightly different. I do not have a lead coefficient, and you do. Whoop-de-doo. What that means is that you're going to have an A term that's not 1. So there you go. All right. I'm going to keep coming back up here and just copy pasting this. Okay. And there we go. So this is obviously not an ax squared, ax squared plus bx plus c equals 0 form yet. So we need to move this 5x over to the correct side. And so what that's going to look like is x squared plus 5x plus 5 equals 0. Okay, so now that we have everything in the correct place, we have our A, B, and C, and they're just handed to us. So this says that B is positive 5. Well, now I make it the opposite of that, and now it's negative 5. Plus or minus the square root of B squared, so 5 times 5 is 25. Minus 4 times A, well, A was 1, and so I'm just going to knock that one out, times C. C is positive 5. All over 2a, and of course my a is a 1, so I can just knock that off. Okay, copy, do this again. All right, 4 times 5 is 20, but this is not a plus. Like the rest of the time, that has all been, positive. It's all come out to where there were 2 negatives, and they added. And tomorrow we're going to see some special cases where these don't come out to be square rootable or positive at all, which means that there can't be a square root of it. And in that case, that's something that you deal with in Algebra 2. So 4 times 5 is 20, and we just keep that negative because there was only one negative. So here we go. And then next line, copy, paste. 25 minus 20 obviously is just 5. And so I can leave it like this in exact form, or I can approximate it. And what I want you to do today is I want you to approximate it. So let's get out the calculator again. Sorry, shut it off. There we go. So negative 5 plus or minus the square root of 5. And the square root of 5 is approximately 2.24. So here I'm going to put 2.24. Okay, and then I'm going to do the math. Negative 5 plus 2.24 divided by 2 is negative 1.38. Now, that was adding. So now it's negative 5 minus 2.24, and that's what plus or minus means. I feel like I should have said that a long time ago, but plus or minus means that you do both of those individually. Okay, so negative 5 minus 2.24 divided by 2 is negative 3.62. And again, those are approximated values, but that is what we're going for. When you get to Algebra 2, you're going to leave a lot of it in exact form because a lot of that is very abstract working. What we're going to be working with is we're going to be doing some approximate real life examples. Okay, so there's that. I'm going to see if I can make some of my stuff a little bit smaller because I feel like this took up a lot of space. Now, the problem with with this in such tiny font is that it is very hard to see, hard to read, and very easy to make big mistakes, actually. So I'm going to make this a little bit smaller, and you can go back and read whatever you need to. This is here for you if you want to use that as a template. If you want to write it out instead, that's your business. This one, yes, I'm pretty sure it is factorable, but I wouldn't factor it just so you can get used to using the quadratic formula. And as you see here, the quadratic formula can be used to solve any quadratic equation. and you can determine the roots of any quadratic equation when you use that. That is actually the algorithm behind how graphing calculators can do this so quickly. Anyway, okay, well, I was hoping that would make it all fit on one page, but it didn't, so my bad. There you go, and you guys have a great rest of the day. Please make sure that you comment any problems that you would like to discuss. In this case, please just make it one of them. All of these line up very closely with the ones that I just exampled for you. So you guys have a great rest of the day, and we'll see you tomorrow. Bye-bye.